Assalamu alaikum class. Welcome to second lecture of first week for wireless and mobile communication. So let me start with the preview of the previous lecture. Actually, in last lecture we discussed the fundamentals of wireless communication system, some basic concepts related to that, and we talked about that there are like all communication systems, the wireless communication system is also divided into three parts, which are transmitter, channel, and the receiver. The important thing is that the channel is actually free space, and the in wireless communication we intend to transmit our voice and data using electromagnetic waves that are transmitted in open space. So that means we need antennas at both ends, at the transmitter and at the receiver end. The transmitting antenna generates the electromagnetic waves and sends it to the through the free space to the receiving antenna, and receiving antenna captures those electromagnetic waves and convert them back into the electrical signal so that it is delivered to the receiver side. So the main idea behind wireless communication is the data transmission, voice and data transmission using electromagnetic waves through the free space. So if we review the electromagnetic wave aspect, we know that the waves, electromagnetic waves, they travel at the speed of light, which is 3 × 10⁸ meter per second. Each electromagnetic wave is generally characterized by its frequency and wavelength, and both of them they are related to each other by the formula C is equal to F lambda, which is mentioned here. That means whenever we are having high frequencies, that means the electromagnetic waves can carry more energy because the photons associated with those high frequency electromagnetic waves, they are at relatively high frequency. But on the other hand, if frequency is higher, because the speed of light is fixed, that means we will end up with a shorter wavelength. So as we go towards higher and higher frequencies, we are actually moving towards a smaller, shorter and shorter wavelengths. This is a typical electromagnetic spectrum. As you know that we generally divide the spectrum into different smaller bands, VLF, LF, MF as listed in the presentation. Our focus in this course will be the radio spectrum, which is indicated as red here. Typically this radio spectrum consists of megahertz frequencies, so we will be focusing on the megahertz frequencies because most of the wireless systems, they are actually designed at these frequencies, and typically this band extends up to 6 gigahertz actually, or we can say up to 10 gigahertz. So basically we will be focusing on sub 6 gigahertz band. So the characteristics of the wave and the behavior of the free space will be whatever we will be discussing here will basically related to this particular frequency band. As an example, if we can see that there are a variety of different frequencies that we use for different systems, and correspondingly we have different wavelengths that are available for the systems. If we talk about GSM phones, a typical frequency for GSM phones operating frequency for GSM phone is 900 megahertz, which represent a wavelength of approximately 33 centimeters. If we talk about Bluetooth applications, which are generally designed at a frequency of 2.44 gigahertz, and eventually the resulting wavelength is around of the order of 12.5 centimeters. If you can see that if you go to the higher frequency, you will end up with a shorter wavelength. Similarly, for satellite communication systems, the typical frequency band that is being used for satellite signals is from 2 to 20 gigahertz. Different satellite systems, they use different frequencies. So the wavelengths for those frequencies are in the range of 1.5 to 15 centimeters. Okay, so this was a basic review for what we already know. Let us move on to the our topic. Our first aspect is actually what is channel. As I said, the channel that is being used, the medium that is being used in wireless communication is free space. So how we characterize a channel? Actually, whatever signal we will be transmitting from the free space is actually is confined to a specific frequency. So generally, we have a well-defined frequency band which is available for a sender or to transmit its data or voice. So that particular frequency band is typically known as a channel in wireless communication systems. That means in free space is not a free space is not a single channel medium. It actually can be further divided into sub frequency bands which represent different channels. So each frequency band that we are using to transmit our information from one end to the other is actually referred to as a channel. So secondly, as I said, each frequency channel is actually is a fixed frequency bandwidth. It has a specific bandwidth, and it is also associated with a specific capacity. What is capacity? Capacity is actually the maximum allowed bit rate that can be transmitted through that particular channel. So whenever we are talking about a specific frequency band channel, that means we have we will be limited the transmission to the particular capacity of that channel. We cannot go beyond that capacity for transmitting the signals from one end to the other. And because we can divide the signal into different frequency bandwidths, that means we can transmit various signals in parallel, and they will be independent to each other because they will be at different frequencies. So actually we can use the free space medium to transmit simultaneously many different signals by sending the signals over different frequency bands. So as an example, we assume that the spectrum of 990 kilohertz is allocated for a frequency to transmit that signal from station A to station B, and we assume that each channel that we are using is actually of 30 kilohertz, and since the total bandwidth is 90 kilohertz and we need channel of 30 kilohertz for each transmission, that means we can have at most 3 channels that can transmit signal in parallel. So you can see from this diagram here, channel 1 is whatever base frequency you are using. It will have the frequencies from that particular frequency up to B plus 30 kilohertz, which is the bandwidth of the channel. Similarly, this channel 2 will occupy the frequency band of B plus 30 to B plus 60, and channel 3 will occupy the bandwidth of B plus 60 up to B plus 90. So this 90 kilohertz bandwidth is actually is divided into 3 channels for transmission between station A and station B. You must note that each channel, it has the transmission capacity of one directional transmission only. That means if we are using channel 1 for transmitting channel A and so transmitting from station A to station B, that means transmission from station B to station A cannot be done through channel 1, because of course if you use same channel for both transmission, eventually they will end up with the interference. So station A to station B, the channel 1 is actually a simplex channel. If we want to use a duplex communication, that means we intend to have two direction bidirectional communication from station A to station B and back from station B to station A. In order to have simultaneous communication, we must use two different channels, which are typically called forward and reverse channels. You can say, for example, if we are using channel 1 as transmission channel for station A to station B, we can use channel 2 as reverse transmission for station B to transmit up to station A. So another option to have this duplex communication is to have time division duplexing, as we will be discussing later. So simply saying, if we are in a simplex communication, that means there is only one channel in which only one station can transmit in a way. So it's a simplex communication. If you have single channel, so only one station will be able to transmit. In order to enable two-way communication, we need to have a duplexing mechanism, which can be a frequency division duplexing or time division duplexing. What does frequency division duplexing mean? So if you have two stations, say a mobile terminal M and base station B, so we have to allocate two different frequencies. First frequency channel will be used for transmission from base station to the mobile station, and second frequency channel will be used for transmission from mobile terminal to the base station. In wireless communication, typically the channel which is carrying signal from base station to mobile terminal is known as forward channel, and the channel which is carrying signal from mobile terminal to the base station is known as reverse channel. The communication link is generally referred to as uplink and downlink. Uplink is a link which is established from mobile terminal to the base station, and downlink is a link which is established from base station to the mobile terminal. So basically, in frequency division duplexing, both forward and reverse channels, they use two different frequency bands. So we need to have two different frequency bands so that there is no interference between the forward and reverse communication. In case of time division duplexing, we actually have only one single frequency channel. We do not need two different frequency channels, but we divide the channel into different time slots. So each terminal transmitting station, like if mobile, for our case, the terminals are mobile terminal and base stations. So each transmitter is allocated with a specific time slot, and it can transmit in its allocated time slot only. So the time between time of communication actually alternates between the mobile station and the base station. First, mobile station transmits to the base station. In the second slot, the base station will be transmitting to the mobile station, and so on. So eventually, at one time, there is only one communication. That means either mobile station will be transmitting or the base station will be transmitting. So in that ways, we can avoid the interference as well, because there will at one time there will be only one communication signal present. So this is generally known as time division duplexing, where we divide the communication between in two directions as two different time slots. This is an example from US cellular radio service. Actually, the initial cellular radio service that was introduced in wireless communication, it had reverse channels and forward channel, and those were numbered sequentially. Like there were channel number 1, 2, 3 in the reverse channel, and there was channel number 1, 2 and 3 and so on for forward channel, and each forward and reverse channel was separated by a 45 megahertz frequency. So channel number 1, reverse channel, which starts from the channel number 991, which starts from 824 megahertz, it transmits. It's a reverse channel, and the corresponding forward channel, the transmission frequency for that channel was decided as 869 megahertz. So the 991 reverse channel and 991 forward channel, they are actually combined together to establish a duplex communication between two terminals. So each pair of communication channels is actually comprises of one reverse and one forward channel. Similarly, for other channels, and you can see that each is separated by 45 megahertz, and eventually this separation is necessary, as we know that if we use the same frequency, eventually that will end up in interference that we do not want in our communication. Okay, so this was a basic idea regarding some concepts on wireless communication and how we use the channel to establish bidirectional communication. At this stage, I feel that we should understand some of the terminologies which are commonly used in wireless systems, because we will be using those terms repeatedly, and I feel that it is very important that you have an idea of these terms. So let us talk about some basic wireless system definitions or some terminologies that we'll be using throughout this course actually, and while doing so I will try to explain the basic architecture of a wireless system as well, so that we get the idea how this system works. So the first term is mobile station. Mobile station is actually any device which is designed to be in motion. It is not bound to have to be at a specific location. You can take the example of your mobile phone. Your mobile phone is actually a mobile station, because you can carry that phone to any location, and even at those locations you can establish a communication. So these mobile stations, they can be handheld personal units like mobile phone, tablets, and other devices. Excuse me. Or these can be installed on any vehicle, because vehicles are also intended for mobility. Important thing is that this mobile station is actually it has to establish communication with the system, so it must have some transmission protocol to provide the air interface to communicate to the base station, and plus it should give an interaction with the user as well, so that it can use that mobile, like for example, you take the case of mobile phone. The user interface is basically provided for with speaker and microphone that are built in that mobile phone. So by speaker you can input your speech, and from microphone you can listen to the whatever voice signal is coming from there. And similarly, it has a keyboard, it has a display to display messages, and at the back end, a mobile phone is equipped with the antennas and other necessary circuitry, so that it can establish the communication with the base station. The mobile station is generally, it has two elements. First one is called mobile equipment, and second one is called subscriber identity module or SIM. Mobile equipment is actually the hardware, and is that piece of hardware that you carry like your mobile phone is actually your mobile equipment, because it contains all the components, all the necessary hardware circuitry, and all the and has built in all the protocols to provide the communication between the base station and the mobile station, as well as it has the capacity to provide an interface for user use. Actually, subscriber identity module is generally is also a hardware component. Is a smart card actually, which is issued by a mobile phone or wireless service provider. It contains the information regarding the services and the address of that mobile user. So if you go and buy services from any company, like for example, if you are interested in buying services from Ufone, so you have to buy a SIM card from the Ufone outlet, so that you can get services from that particular SIM card. And you can see that both of the pieces, they are important, because mobile equipment is actually, it provides all the necessary hardware for communication purposes, and SIM card which is required for the subscription, that provides the information to the service provider, that what type of services you will be using and how you will be using those services. So basically that is your address, that carries your address in this wireless communication world. While defining mobile station, I use the term base station. Base station is actually is a fixed radio station which is generally mounted on top of a tower. So it is equipped with large antennas, and you might have seen different base stations, actually not base stations, are towers at different places, and you can see that is a large tower. Generally the intent of the base station is to provide a coverage over a larger region, and it also have necessary equipment to establish the communication. One important thing is that mobile station is actually responsible for one user's data. Like your mobile phone is actually for single person use. You can have generally sometimes you use dual SIM phones as well, but generally it's only for a specific number of users. So only responsible for one user data transmission and reception. But the mobile station, they are capable of handling large number of subscribers simultaneously. So when a mobile station is in operation, so depending on the available number of channels, so it may be communicating to the number of subscribers present in that particular region. Subscriber, the term subscriber is also defined here. The subscriber is someone who pays the subscription charges to use the mobile communication systems. Like if you buy a SIM card from Ufone, as I said, as I gave the example earlier, so you will be a subscriber of Ufone, and you will be paying the subscription charges to Ufone to get the necessary services that you want. Okay, coming back to the base station, generally base station have two major parts. First one is called base transceiver station, or BTS, and second is called base station controller, or BSC. What is base transceiver station? In order to first question is what is the transceiver, because in mobile communication, each station is intended to have a duplex in order to establish duplex communication, each station is required to have transmitter as well as receiver. So if you are using a mobile phone, at some point you will be transmitting, at some point you may be receiving the signals. So it has both built-in transmitter and receivers. So the combined term for the transmitter and receiver is transceiver. So transceiver is actually a device which is capable of simultaneously transmitting and receiving radio signals. So what is base transceiver station? Is actually the transceiver of the base station. So basically the data transmission is done at the BTS, the communication from base station to the mobile station or from mobile station to the base station goes through this BTS because it is equipped with the necessary circuitry and the antennas to establish the communication. Base station controller. What is base station controller? A base station controller is a critical mobile network component. Actually, it provides a controlling function of BTS. It's not necessary that each BTS has a dedicated base station controller. Sometimes one base station controller controls the function of more than one BTS or as we call them cell sites, more than one cell sites, but it's important because it controls all the function and coordinates and manage all the functions that are required by the BTS. For example, key base station controller function include the radio network management, which channel to use, it decides which channel will be used for transmission and how that will be transmitted. BTS handover management, sometimes handover is needed between different BTS, so it manages that handovers. When a call setup is requested, the base station controller takes up that call setup request and eventually decides and it eventually makes the necessary controlling operations to set up the call. Another important component of that mobile system, a wireless system, is mobile switching center. It is actually the main component that is a main switching center which provides a connection between different base stations as well as to the traditional public switch telephone network or PSTN as we know that. So it's basically the switch that communicates with the PSTN in that particular region, plus it communicates with the base stations that fall in the coverage region of that MSC, and it also coordinates or communicates to the other MSCs in the coverage region of service provider to establish communication. So basically MSC coordinates routing of the calls in a large service area. If a mobile station initiates a call that has to go to a landline phone, so eventually that call is controlled by that MSC, and MSC makes a connection with the PSTN and make a route for the call so that it can communicate to that particular landline phones. Or if a call is made to other base station, the other cellular phone, eventually the MSC is associated with both base stations. They coordinate with each other to establish a call. In wireless system, the mobile switching center is sometimes known as mobile telephone switching office as well. So we sometimes refer to MTSO for this purpose. There are some integral parts of MSC which are home location register, visitor location register, authentication center, and equipment identity registers. So let me show you a basic architecture how this system works, and then we'll talk about these different components. So this is a architecture of a basic wireless system. In the left side, you can see the first box is actually a mobile station, which is actually comprising of a mobile equipment and a SIM. The mobile station connects to the BTS, which is controlled by BSC, forming a base station subsystem, which actually connected at the back end with MSC, and MSCs are connected to the PSTN and ISDN lines to establish communication. So all these networks, they are connected together to establish a communication at between two different subscribers. Okay, coming back to definitions, the home location register, which is actually part of MSC, actually whenever you go and someone buys a subscription from any service provider, so the subscriber data is actually saved at a register which is known as home location register. So if you are getting services from a specific subscriber, so whatever MSC is serving the area you are in, that MSC will store necessary location data related to your subscription in this HLR. Sometimes it happens that we travel to other locations and we go beyond the coverage region of our MSC, and if we are at a coverage region of some other MSCs, so that MSC gets the data from the home serving MSC and store in a temporary register which is known as visitor location register, or VLR. VLR stores the necessary information that are needed by MSC in order to provide the necessary services. So if you are in some service area of some other MSC, so that MSC would be having the necessary information about your subscription, so that it can establish fault whenever it's needed. Then MSC also has an authentication center. Actually, it is very important to provide the information security for the user. Generally, each SIM card has a secret stored key which is used for encryption of the data and voice that is being sent by the particular equipment. That authentication center at MSC, it has a protected database that stores the secret key which is available with the subscriber, so that the information can be checked and authenticated before transmitting, and the information can be protected from any illegal use. The MSC also has another important component which is known as equipment identity register. It has the information regarding all the valid mobile equipment which are available in the network. Generally, that information is stored with reference to the International Mobile Equipment Identity Number, IMEI. As you know that all the mobile equipment, they have a certain IMEI number, and its unique number allocated to each device throughout the world. So your IMEI will be same no matter where you go. It will not be duplicated anywhere in the world. So actually this IMEI provides an information about valid equipment. This equipment identity register which stores the IMEI information, provides the list of valid equipments which are available, and if some IMEI is marked as stolen or invalid, so eventually that particular IMEI based device will not be allowed to establish communication on that particular network. So that was a few terms related to the wireless system, and while doing so I tried to give a picture, a block diagram of a simple architecture of wireless system. The second aspect of that wireless system is channel. As I said before, channel is range of frequencies that are allotted to a particular service or system. There are a variety of different channels that are used in wireless communication. Generally for each communication we have a control channel which actually takes up the information regarding all the controlling purposes. Actually these channels are used whenever there is a call setup request or call initiation or whatever control purposes that we need to use. Generally we use those control purpose, we use that control channel to perform those control functions. There is a voice channel which is actually used for voice or data transmission. So once a call is set up through control function, it is handed over in the voice channel so that which can be used for voice transmission or data transmission. As I said, because we intend to have duplex communication, so we generally have forward and reverse channels. The forward channel is the one which is used for transmission from the base station to the mobile, and reverse channel is the one which is used for transmission from mobile to the base station. And you can expect that, of course, there are control channels which is restricted to the forward channel and voice channels which are restricted to the forward channel. So there are forward control channel and forward voice channel. Similarly, there are reverse control channel and reverse voice channels. So this is a summary of different types of systems. Of course, we for mobile communication systems we use full duplex communication because we intend to have a simultaneous communication, two-way communication between two stations, and those stations need to have the communication at two different channels. Of course, as I said, we need to have two channels, so that will be frequency division duplexing, which is very commonly used in wireless systems, or it need to have time division duplexing. Sometimes we use simplex systems like TV remote is actually a simplex system. It also transmits the data from one terminal, which is your remote control, to TV, but it requires only one-way communication. So we sometimes have simplex system as well. Sometimes we have half duplex system. In half duplex system we have one channel, but we use the same channel for communication, two-way communication, which is so at a given time only one station is allowed to transmit or receive, allowed to transmit the information. So actually that is a kind of time duplexing where one station transmits at certain time, and then when it completes its transmission, the other station starts transmitting. Okay, one of the important aspect in wireless communication is actually handoff. As we discussed in our last lecture, the wireless systems they have mobility. They are designed to support the mobility, and while the mobile station is in movement, there are possibilities that it goes beyond the coverage region of a specific base station. So if you are in a specific base station region, for example, and a call is established with some other subscriber, and you start moving away from the base station, eventually at some point you will not be able to communicate that base station. In that scenario, the base station controller has to decide that it will shift your call from that particular service base station to some other base station in the region. So this process of transferring the mobile station from one channel to another or from one base station to another is actually known as handoff, and this is a direct consequence of having mobility in the system. So eventually that mobility leads to the some handoff management strategy as well. A roamer or roaming is actually another important thing. The mobile station. A roamer is someone which operates in a service area or market which is other than the originally subscribed area. So if we move into a region which is not actually which is not the market of our service provider, we will be in actually a roaming mode. A page is actually a brief message which is broadcast over an entire service area. Usually it is broadcasted by many base stations at the same time, so that that message is reached to the all the users or subscribers in that particular service area. Generally, this paging is used to provide some critical information regarding services or other information that can help the subscribers. Okay, so I think this is the end of our today's lecture. Let me quickly summarize what we discussed. We actually in this lecture we tried to define some basic terminologies that we will be using for this course. Actually, these are some common terms which are used in wireless systems, and we repeatedly use those terms for whenever we talk about the wireless communication systems. So that's it for today's lecture. So see you soon, inshallah, with next lecture. Thank you all.